Alright guys, sorry for being out today. I'm even more sorry for the fact that I don't have anything that I need with me, like my computer or my stylus, so we're going to try to teach you today's lesson the old-fashioned way, just with paper and pencil. So before we start the lesson, just make sure that you guys know that anytime you need to pause the video, make sure you guys pause it in case you need to write anything down, and then make sure if you get confused by something, you write it down so you can ask me later. Or you rewind so you can watch that part again. Okay, we left off yesterday talking about independence. Now we said independence are when you've got given information, so probability of A given B, but this given information should not have any impact on the results. So if I've got the probability of A given B, then that should be the same as just the probability of A. Alright, so for example, we talked about two events. Let's say A was the probability or the event where I was going to bring a sandwich in for lunch. Okay, and probability B, or event B, would be the probability of it raining. Okay, so in this case, the probability of A given B is talking about the probability of bringing a sandwich given that it was raining. So the fact that it was raining should have no impact on whether I bring a sandwich in or not for lunch. So it should still be the same for the probability of just bringing a sandwich in for lunch. Okay? And if it's independent, the opposite should also work. So in our case, the probability of B given A should still be the same as the probability of just B. So in my case, the probability of it raining, given that I brought a sandwich in for lunch, well, me bringing a sandwich in for lunch is going to have no impact on whether it rains or not. So the probability of it raining should not change. Okay, so if you're going to do independent checks, and they ever tell you to check for independence, you have to check both situations. The probability of A given B should be the exact same as the probability of A, and the probability of B given A should be the exact same as the probability of B. So let's give an application to this so you guys can understand it a little bit more. Okay, let's say we've got two events. Event A would be picking a 7. Picking a 7 from a deck of cards. A full deck. Okay, and we'll say event B would be picking a red card from a full deck. And I want to know, are these events independent? Okay, so in order to do that, the first one I'm going to check, so the probability of A given B should be the exact as the probability of A. In our case, what that means is the probability of picking a 7, knowing that I'm picking a red card, should be the exact same probability as just picking a 7. Okay, so what we learned yesterday is there's a formula for this. The probability of A given B, that would be the exact same as the probability of picking a 7 and a red card over the probability of just picking a red card. That's from our formula. Sorry, let me scroll up. That was from our formulas yesterday. Okay, so if I'm looking at a deck of cards, how many cards in a deck are 7 and red? So for me, the probability of picking a card that's a 7 and it's a red card, there are 2 cards out of a full deck of 52 that are 7 and red. over what's the probability of picking a red card. How many red cards are there in a deck? Well, there are 26 red cards in a full deck, so 26 out of 52. So since these denominators match, those 52s are going to end up canceling, and we're going to get 2 out of 26, or 113. Okay, so that was just the first half. I want to know, is that exactly the same as picking a 7? Okay, that's what I'm checking for. So, probability of picking a 7, how many 7s are there in a full deck? Well, I've got 4 7s in a full deck of 52. And if I reduce 4 out of 52, guess what I get? 1 out of 13. So because these are equal, that means that there is a chance that they are independent. Okay. However, in order to check for independence, we said there are 2 checks. We check that the probability of A given B is the same as the probability of A. We have to do the opposite of that, or the reverse of that. We also have to check if the probability of B given A is exactly the same as the probability of B. All right, so in our case, is the probability event B is picking a red card. So it's the probability of picking a red card, given that it's a 7, the same as the probability of picking a red card. All right. To find this probability on the left side, I'm using the formulas from yesterday. This would be the probability of picking a red card that's also a 7 over the probability of picking a 7. Okay, so again, in the deck, how many red cards are there that are also 7? So 7 that are red. There are 2 7s in a deck that are red. Over how many 7s are there in a deck? Well, I've got 4 7s out of a total 52. So in our case, on the left side, this becomes 2 over 4, which reduces to 1/2. Okay, so probability of picking a red card now. So I want to know, are those equal? Well, how many red cards are in a full deck? Well, I've got 26 red cards in a deck of 52, and 26 over 52 reduces to 1/2. So these are equal as well. So if you notice, when I do both checks, on the left side they're both 1 over 13, on the right side they're both 1/2, so that means that these two are independent. And there's the checks that prove it. Okay, so what this tells me is the idea of picking a 7 or picking a red card, those two have no impact on each other. So whether I know whether the card is red is not going to change the probability that I'm picking a 7. Or knowing that I picked a 7 is not going to change the probability of me actually picking a red card. These given values have no impact on the final probability. Okay, now these events were independent. Not all of these card situations are. So let me give you another situation of events that are not independent. Okay, so going along that same route, let's do event A. Come on, focus. There you go. Let's say event A would be picking a heart. And event B then would be picking a red card. Again, if I was checking to see if they're independent, I want to know, are these two things independent? So that would tell me that the probability of A given B should be the same as the probability of A, and the probability of B given A should be the exact same as the probability of B. Okay, so I'm going to check the one on the left first. So in this case, probability of A given B would be the probability of picking a heart given that it's red should equal the same as the probability of picking a heart. So in our case here, probability of picking a heart given that it's a red card, that's the probability of picking a heart and a red card over the probability of picking a red card. Okay. How many cards in a deck are red and also hearts? So there are, for me, there are a total of 13 cards in a deck that are red and hearts as well. 13 out of 52. Over how many red cards are in a deck? There should be 26 over 52. Half the cards are red. So those cards cancel. I get 13 over 26, which reduces to 1/2. Okay. Now on the other side, I want to know, is that the exact same as the probability of picking a heart? Well, how many hearts are there in a full deck? I've got 13 hearts in a full deck of 52, and when I reduce that number, I get 1/4. So because these are not equal, we know right away that they are not independent. I don't even have to do the other check. If one of them doesn't work, we're guaranteed that they're not independent. So you can say that they're not independent, or you can say that they are dependent. Okay, it doesn't matter which verbiage you use. Okay, so there's a situation of something that's independent, and there's a such situation of something that's not independent, just so you guys can see. So what this tells me is knowing that the card is red is going to change the probability of me picking a heart, or vice versa. If I knew that the card was a heart, that would change the probability of me picking a red card. Okay, so there's the final touch-ups on knowing how to prove that something is or is not independent. Okay. So, based on whether these things are independent or not, we have some multiplication rules. Usually when you talk about multiplication rules, we're talking about multiple events. Okay? And the most common multiplication rule, it actually comes from the given formula that we have. So let me show you this. If I said you have the probability of A given B, and yesterday we learned that was the probability of A and B over the probability of B, right? This is on your formula sheet. I can very easily turn this into a multiplication rule by getting rid of this denominator. Well, how do you get rid of this denominator? Well, you can cross multiply it up to the top. Okay? So when you cross multiply it, this would be the probability of B times the probability of A given B is equal to the probability of A and B. This is your multiplication rule. Now, in the situation where the events are independent, we just learned if they're independent, then the probability of A given B is exactly the same as